Today we're going to be doing classifying matter, part 2. The main concept that we're talking about today is that all matter has physical properties, and those physical properties can be observed to determine how matter is classified, and we can make assumptions on how matter is used based on those observations. So one way that we have been classifying things since we started properties of matter is by putting them in groups of considering their state of matter. So solid, liquid, and gas. Right? We've been classifying things like that for a couple weeks now. Talking about solids, liquids, and gases. We can group all solids together. We can group all liquids together. We can group all gases together. But there's way more ways to classify things. We can classify based on gender, boy or girl. We can classify based on hair color, eye color, height. We could classify based on which teacher we have, or we could be classified based on what activity period we have. Loads of different ways we can classify whether something is, let's see, hard. I don't really have anything. Here we go. We can classify something based on whether a solid is hard or whether it is soft, whether it is rigid, right, doesn't bend, or it is flexible. We can classify on whether something is, what do we got? Here we go. Something is round or flat, right? So we can, any way that we can think of describing something that we see, describing the physical property of something, any way we can describe it, we can potentially classify it that way along with other things that also fit that classification. Today, we're going to be testing about 8 different items to check some of their physical properties and make some observations. So, we should be working on this page here. This is our classifying matter, part 2. All right, so we're going to fill this table out together, and then we will talk about these answers, but I'm going to let you answer those on your own. So let's get started. First thing we're going to do is we're going to check for if something is an electrical conductor. Then we're going to test if each item is a thermal conductor. We're going to test if each item is magnetic. And we're going to test if each item is reflective. So one vocabulary word we need to talk about right here is conductor. A conductor is any material that will allow energy to pass through it. And the opposite of conductor is insulator. An insulator is anything that does not allow energy to pass through it. So we can do that looking at this right here. This is a battery-powered electrical circuit. Basically, you see our light bulb here is not on because there is no electricity running all the way around. To make electricity run, or to make electricity power something, we have to create what's called a closed circuit, meaning all of the electrical parts must be in a loop. So as you can see, these pieces are not in a loop because these 2 wires are separated. Right? So we have 2 wires coming off the battery. This one comes up onto our light fixture. Then another wire comes up and stops. And this end, the wire comes around and just stops. So right now, this circuit is not complete. The electricity cannot make a complete loop, so the electricity is not running. But as soon as we allow the electricity to make a circuit, or to make a full circle by connecting these 2 wires, we can see we get some light, right? So as soon as these 2 metal ends here touch, our electricity flows, and we get a closed circuit which lights our light bulb. Now let's talk about conductor and insulator really quick. If you'll notice, this wire here is 2 different colors. There's a metal side and a white side. And you can see on this one the same thing. There's metal, or there's a silver part and a white part. Most of these wires are white. See how most of the length of this wire is white. That is because the metal here, the silver, is a metal, and metal is a conductor of electricity. So if we were to touch these two metals together, remember a conductor is anything that allows energy to flow through it. Metal allows energy to flow through it. So when we connect them, the electrical energy is flowing. Uh-oh, the light bulb came off. There we go. Electrical energy is flowing through it, which is what we want. Now, this white casing on the wire is rubber. Rubber is not a conductor. Rubber is an insulator. An insulator does not allow energy to pass through it. So if we connect these two conducting materials, we get light because it's metal on metal and they conduct. But if we touch the metal to a white area, the white is a rubber insulator. So if we touch this metal to the white area, the white rubber stops energy from passing through it. So it does not let electrical energy in, which is why our light bulb is not lighting up, because the white rubber is an insulator and is not letting the electrical energy pass through. And as soon as we move back to metal on metal, we get some electricity flowing again, and as soon as we go off, we lose it. So that's just a quick lesson on what a conductor is, right? A conductor allows energy to pass through it. It could be electrical energy, it could be thermal or heat energy. So a conductor allows energy to pass through, like the metal. An insulator does not allow the energy to pass through. That is why I can safely hold these wires without feeling any electricity going into me, because I'm holding an insulator, and the insulator is not letting the electricity pass from the wire to my fingers. Okay, so to test these, we're going to start with our metal spoon, and we'll go down and we'll check each one. All you have to do is write a yes if it isn't an electric conductor, or no if it is not an electric conductor. So as we know, if we touch these together, it creates a circuit. So all we have to do to test if these can be a circuit, I'm going to place this first item, a metal spoon. I'll touch one to one side, and I'm going to touch the other metal wire to the other side, and if the bulb lights up, then we'll know that energy is flowing through the spoon, and we'll know that the spoon is acting as an electric conductor. So what do you think? Is the bulb going to light up, or is it not? Let's find out. All right, we're getting a little electricity flowing. There we go. All right, we see that? Very good. So electricity is moving from this wire into the spoon, and then up this other wire, back around to the light bulb to cause an electrical reaction. So electrical energy is passing through the spoon, so we can say that the spoon is, yes, an electric conductor. All right, let's check next. Let's do the iron nail right here. So I'm going to wrap this one up a little bit. And I will, so that one's on. We'll wrap this one on here. Oh, we already got a little action. And holding these two on there. Very good. So once again, the iron nail is allowing electric current to pass through it. So the iron nail is a conductor. All right, so iron nail is a yes. All right, aluminum foil. This is what you have in your house. Pretty common, a lot of times used for leftovers. Never put this in the microwave. Never, never, never put aluminum foil in the microwave. All right, so I'm going to put one wire in, and what do you think is going to happen once I get this other wire set up? You think it will or will not conduct electricity? 3, 2, 1. Whoa, nice. All right, so we are once again conducting electricity. Our light bulb is on because electricity is passing through the aluminum foil. Very good. So aluminum foil. All right, next is a wooden spoon. What do you think will happen here with the wooden spoon? You think it will or will not conduct electricity? Let's wrap and put this one on, and no light. No light. So we are not getting electricity to pass all the way through. So the electricity is coming up the wire, it's going in here, but as soon as it hits the wood, it does not connect to the other side. This wood is not conducting electricity. The electricity is on this wire, it hits the wood, and it stops. The electricity is on this wire, it hits the wood, and it stops. So the wood is not allowing energy to pass through it, not allowing electric energy to pass through it, so the wood is not a conductor. Next is let's see, we're on to the plastic spoon. What do you think? Do you think this plastic spoon is going to allow energy to pass through it? Will this plastic spoon be a conductor? Nope, it will not. So plastic spoon is not a conductor. I'm going to let you fill that one out. An eraser. What do you think? Think this eraser will be an electrical conductor? Well, erasers are made of, do you know? Made of rubber. And we already talked a little bit about whether rubber is a conductor or an insulator whenever we were talking about this white casing around the wire, right, to keep me from getting shocked. But let's find out. Put one on, and nothing. Nope, no electricity. Dim, dim, dim light bulb. All right, so that does not conduct electricity. Cotton ball, what do you think? Yes, no, maybe? Let's put one side and the other. Nope, again, no electricity being conducted. Okay. And the last item is a mirror. Let's see, there he is. Hey, all right. So put one side on this mirror and another side, and we are not getting any. Oh, it's me. We are not getting any electrical conductivity. So the mirror is not an electrical conductor. All right, I'm going to let you fill those spaces out. Let's come back up. So we are finished with the electricity. Now we are going to do the thermal conductor test. So thermal means heat or temperature. All right, so if something is, the items that were an electrical conductor allowed electrical energy to pass through it. So if these items are a thermal conductor, that means they will allow heat energy to pass through it. So I kind of already have this set up. You can look over here. If we check out our gecko's terrarium right there, you'll see that up here, this lamp right here is a heat lamp or a thermal lamp. Basically, this lamp is providing a heat source for the geckos that we have in the terrarium here. So it's always on for the geckos, but now it's kind of serving an additional purpose. If you see right here on top of the cage, I have another set of our items that have been over there attempting to absorb heat from that heat lamp. So I'm going to go get those real quick. All right, if these items are warm, that means that they are absorbing they are absorbing thermal energy, and it means that they are a thermal conductor. So very simple. I'm going to turn this down. I will feel these these items. You got to move kind of quick, otherwise they'll start cooling off on their own. So let's go ahead and check. Let's get a focus in. There we go. All right, so thermal conductor, metal spoon. The metal spoon is pretty warm. Yep, so the metal spoon did absorb some heat. So the metal spoon is a thermal conductor. What's next? Iron nail. What do you think? Yes, the iron nail is warm. It was also absorbing heat. So the iron nail is a thermal conductor. Next, aluminum foil. What do you think? Another metallic substance, metallic material. This is warm. Yep. So this also feels like it will be a thermal conductor. Okay. Next is a wooden spoon. What do you think? Yeah, the wooden spoon is not warm at all. Not warm at all. So it did not absorb the thermal energy. So wooden spoon is a no. Plastic spoon. Plastic spoon is pretty warm. Yep, this one is pretty warm. So this plastic spoon did absorb some thermal energy. So this one is a thermal conductor. Again, I'm not going to write those. I want you to fill these out since you make sure you've been paying attention. The rubber eraser is not warm at all. Nope, no heat. Cotton ball is not warm at all. Nope, no heat. And this plastic mirror is not warm either. So I think, so a glass mirror definitely would have absorbed some heat because glass is a thermal conductor, but this plastic mirror, this plastic is not absorbing that heat. So that's interesting that this plastic spoon was warm and this mirror was not, even though they're both plastic. It could be because they're different types of plastic. It could be because the mirror went last, so by the time I touched it, it had cooled down. But that's science. Sometimes you're going to get surprised. All right, and last, next to last, we're going to do magnetic. This one's super easy. All I'm going to do is touch each item. I have a magnet here, very simple, north and south pole. All I'm going to do is touch each item in sequence and see if it sticks. So, metal spoon, and I'm not going to fill these out. I'm going to let you fill these out. So, a metal spoon, is it magnetic? Yep, it sure is. All right, iron nail, is it magnetic? Yep, it sure is. Aluminum foil, is it magnetic? Nope, it is not. All right, wooden spoon, is it magnetic? Nope, it is not. Plastic spoon, what do you think? Magnetic? You probably got that one right. Nope, plastic's not magnetic. An eraser is, no, not magnetic at all. Nope. A cotton ball, you probably already guessed it. Cotton ball is not magnetic, and a plastic mirror is also not magnetic. All right, so we had the metal spoon and the iron nail were magnetic, but the rest of them were not. And lastly, we're going to test for reflectivity. So for this one, we will be using a laser pointer, okay? So, right, standard laser pointer. You probably have been told not to shine this in people's eyes, which is true. You might have played with a cat or a dog with it. My cat loves these. This laser pointer shoots out just a laser beam of light. And we're going to use this to test if items are reflective. Because if something is reflective, that means it will, any light rays that hit it will bounce back off. So right now you can see that our skin is not very reflective, right? This laser beam is not bouncing off onto any other item around us. But if I put it on this metal spoon, which you can already see is reflective, if I shoot the laser on this metal spoon, look, see, I'm shooting this laser up, but you see that laser on the table as well because the light beams are traveling up, hitting the spoon, and then bouncing back down onto the table. So this spoon is reflective. So the metal spoon is reflective. Next is the iron nail. This one might be kind of hard to see. Let's see. Yep, we got some reflection there. See it right under? Well, let's see. We had it for a second, I thought. Yeah, there we go. See, look at it on the paper a little bit under. Let's see if I can go that way. There you go. You can see it about right here. There, yep, there's some reflection. Very good. So the iron nail is causing a reflection. All right, the aluminum foil. Oh yeah, that's a fun one, huh? Look how the different angles of all the creases in the foil, the different angles are shooting the light into a bunch of different directions, or a bunch of different minute angles, which is causing that diffracted look. Pretty cool. So aluminum foil is reflective. Wooden spoon. This one you can see through, right? The laser beam is going to be seen through, but are we seeing? This is not a reflection. This is just light passing through the item. So we're looking for the table. Do you see a reflected laser beam on the table? We do not. Not coming anywhere around. So a wooden spoon is not reflective. Plastic spoon. I mean, we can kind of see the reflections in this one already. So once again, that's not the reflection. That is, look about right in this area here. There it is. Look at the tip of my finger. You see that little bar of light? That is the reflection of the spoon. Remember, this on the back of the spoon is not the reflection. That is from the light passing through. You're wanting to look about right here in this area. And you will see, find that angle again. Well, hopefully you saw it earlier, because it was definitely there. Let's see. Well, should be on here somewhere. Well, if you didn't see it, you can back it up, look for it. It was on there. So, plastic spoon was reflective. An eraser, what do you think? Reflective or non-reflective? See, we're not getting any reflected light back onto the table, so the eraser is not reflective. What's next? Cotton ball. Definitely looks cool when you get the light shining into it, but this is not reflective. And last thing is a mirror, which we should already be able to know that this is going to be pretty darn reflective. Yep. See? Very reflective. There you go. Okay. So, I hope you were paying attention when I went through all of these. If not, feel free to back the video up. That is not a problem. Take your time, get these corrected, and then we'll use this table to answer these questions. So if you want to pause the video to go back and get this caught up, that is perfectly all right. And when you're finished, come back and we will go over these questions right here. So, number 2, what types of materials were reflective? So look up at the chart. There were only, we did 8 items, but only 3 of these were reflective. Yep, so only 3 of these, well, maybe a little more than 3. Our metal spoon, iron nail, aluminum foil, plastic spoon, and mirror. So these 2, plastic spoon and mirror, are both made of plastic. These 3 that were reflective are all made of metal. So it says what type of materials, or what type of material were all, well, I totally messed that up. I was reading the wrong one. Here we go. I'm sorry. I got confused on my questions. Okay, back it up. We're on number 2. All right, talking about what types of material were reflective. Well, we saw that the 3 metal items were reflective, and we saw that the 2 plastic items were reflective. So the 2 types of items that were reflective were metals and plastics. Let's see, moving down to number 3. What type of materials were all of the electrical conductors made out of? So all of our electrical conductors were made of the same type of material. What kind of material is that? They are all metal objects. Very good. So they are, right, the metal spoon, the iron nail, the aluminum foil are 3 different metal materials, and they were all electrical conductors. So for 3, we just discovered that probably all metals are going to be good electrical conductors. Number 4, are all metals magnetic? So you have to come up to your boxes right here. Remember, these are your 3 metals. So our metal spoon, was it magnetic or not? Was our iron nail magnetic or not? And was our aluminum foil magnetic or not? So using that information, answer, are all metals magnetic? And number 5, which materials made the best thermal conductors? Well, remember we saw, and we still have it listed here, that our 3 metal objects were all thermal conductors. And I think the only other one that was a thermal conductor would have been the plastic spoon. So, which materials made the best thermal conductors? You didn't get a chance to feel it since it was on the video. I did, and it was definitely these up here. These were definitely the best thermal conductors right there. So, what to take away from this? Well, remember the concept we talked about in the beginning. Remember the concept we talked about in the beginning was that all matter has physical properties. We can observe those physical properties by looking at them or testing them or touching them or feeling them. We can observe those physical properties, and then we use those physical properties to put items or substances into different categories, like solid, liquid, or gas. Or we put them in to a category like we did here, which would be, we just grouped these metals as electrical conductors. That's what we classified them as. We can, from our data right here, we can also classify metals as thermal conductors. All right. We could say that the eraser and the cotton balls could be insulators, since they did not allow electricity or heat to pass through them. So the purpose of all this is just to understand that if we observe something, right, and we note the physical properties that it has, size, shape, thermal conductivity, electrical conductivity, hard, soft, rough, smooth, any physical property can be observed about something, can also be used to classify those things. So don't forget, finish answering those questions at the bottom if you didn't. And tomorrow, your next lesson will be Classifying Matter Part 3, which is where we will investigate some mystery substances, make some more observations, and see if we can use some clues to determine what these 5 mystery substances are. So thanks, and we will see you next time.